So to find the free energy change, I'm going to be using the equation delta G equal to delta G naught of reaction plus R, our gas constant, times T, our temperature, times ln K. So first we have to find the delta G naught of reaction and the K to complete our equation. So first, to find the delta G naught of reaction, we have to use the values from the appendix G, which I found ahead of time. So dinitrogen is equal to 0, H2 is equal to 0, and NH3 ammonia is equal to negative 16.5. So now I enter that into our equation to find our delta G naught of reaction. So it is going to be 2 times negative 16.5 minus 1 times 0, and then our plus 3 times 0. And then calculate that. 10.5 and we should get negative 33. And for sig figs, it's going to be delta G naught of reaction is equal to negative 33.0 kilojoules per mole. Next, we have to find our K. So to find our K, we're going to do K is equal to our products divided by our reactants using the dinitrogen moles and the dinitrogen, hydrogen, and ammonia moles that are given in the equation. So it is going to be 0.455 squared divided by a reactance of 0.075 times 0.150 cubed. So now I calculate that. Okay, so that gives us 817, but we have to have 2 sig figs, so we're going to round that to 820. So our K is equal to 820. There's our K. So now that we have our delta G naught of reaction and our K, we're going to input that into our final equation. So we also have to convert kilojoules to joules, so it's going to be, instead of negative 33.0, it's going to be negative 33.0 times 10 cubed joules per mole plus our gas constant of 8.314 joules per mole Kelvin times our temperature of 298 Kelvin times our natural log of 820. So here's everything into the equation. So now to calculate that, there we go. So we get negative 16,377. But for our sig figs, we're going to do negative 1.6 times 10 to the 4th joules per mole.